Welcome to AP Chemistry. I am Mr. Johnson. This is the first unit in AP Chemistry. We're going to call this Unit 0, and for the first question might come up, why the heck are you calling it Unit 0? Why don't you just call it Unit 1? Well, because Unit 0 is introductory information that isn't necessarily specifically tested on the AP test, but it is information that will help you to answer questions that are specifically covered on the AP test. So we're going to call this Unit 0. So when you're studying for the AP test later on this year, you're probably not going to be studying this stuff from Unit 0, but again, this stuff will kind of help us understand a lot of the things we're going to do this year. So first of all, let's talk a little bit about chemistry. Okay, chemistry is amazing. First of all, there's so many things around you every single day that involve chemistry, and you don't realize it, but turning your car on when you drive to school, when you unplug your phone and the battery starts to go down, when you take ibuprofen when your muscles are sore, when you have a headache. Even here on the screen, you can see that some things that involve chemistry, lighting a match. Think about developing medicines for cancer or developing vaccines for certain diseases, maybe coronavirus or something like that. Even something as simple as ice melting and water evaporating and turning into a gas, all of those things involve chemistry. And chemistry, again, is the study of matter. Okay, and matter, what the heck is matter? It's everything. It's all of the physical material of the universe. And anything that has a mass and takes up space is considered matter. So some of the things that when we think about matter, some of the things that are made up of matter is air. Air is made up of matter. The sun is made up of matter. Water is made up of matter. Dirt, clouds. The only thing that you might think of that is not made up of matter that you might think about is energy. Okay, energy is not made up of matter. Energy is like light, heat, things like that. Okay, and then all of the matter that exists in the universe, we can separate out into what are called elements. As we know that the periodic table of elements is everything that exists in the universe. And the elements are made up of atoms of that element. So we call atoms the building block of matter, and each element only contains one unique type of atom. And then when you put multiple atoms together, you can form what's called a molecule. And the term molecule this is an important part here, is when you have two or more non-metals that are joined together. Okay, there's another word that isn't on here that's called a compound. And again, as I'm underlining things and writing things down, hopefully you're doing the same thing. So a compound is very similar to a molecule, but that can be, same thing here. It can be two or more nonmetals together, but it could also be a metal plus one or more nonmetals. So compounds kind of encompass the whole periodic table, where when you use the term molecule, molecules are just for nonmetals, such as water. Water is made up of hydrogen and oxygen. Many times you hear of the term a water molecule. Okay. States of matter, again, hopefully this is mostly review. Matter can be in the solid form, the liquid form, or the gaseous form. Gases, as you can kind of see below, this one here would represent the gases, where they don't have a fixed volume or a shape. They basically just fill up the container that they are in. They are far apart from each other. The particles are far apart from each other. They move at very high speeds, and they do collide very, very often. Okay, whereas here we would have the liquids. Okay, and liquids do have a distinct volume, but obviously they don't have a shape. Whatever you pour that liquid into, that's the shape it's going to have. But it does have, if you have a gallon of milk, well then that's the volume of that liquid. Certainly, as you can see here, the particles are they're packed more closely together, and they can move around each other much more than in a solid. Okay, and then here on the left-hand side, as we do have a solid, Solids do have a definite shape and a definite volume. The molecules or atoms are very tightly held together and they might vibrate a little bit, they might rotate a little bit, but again, typically in a solid, there's not a lot of motion as you get like with liquids and with gases. Okay, and another one you're going to see quite a bit in this class, which isn't shown here, is what is called the aqueous state. And it's abbreviated with an AQ. So if you see something like NaCl and then it says AQ afterwards, what does that mean? It means that that solid is dissolved in water. So that means you've taken some salt and you've put it into some water and you have created, again, what's called an aqueous solution. Okay, and you will see that quite a bit in this class. Okay, now, once we talk about matter, there's two different ways that we can talk about matter. Okay, one of them is matter can be a pure substance, or matter can be in the form of a mixture. Okay, a pure substance is matter that has distinct properties and the composition doesn't vary from sample to sample. Which means that, for example, the elements and compounds, those are two examples of pure substances. And what that means is it means that like carbon dioxide, for example, is always 100% of the time CO2. Okay, if we're talking about carbon dioxide is always CO2. If we're talking about helium, it's always just atoms of He. Okay, and that doesn't vary. See how it doesn't vary from sample to sample? CO2 is always one carbon and two oxygen atoms. Helium is just made up of helium atoms, etc. Okay, the difference is down here with mixtures. Okay, mixtures obviously they do vary from sample to sample, which means that when you put things together, sometimes it's not always one carbon and two oxygens. Okay, so a mixture is, again, different substances combine, but they retain their own chemical identity and properties. If you put salt in water and you boil off the water, what's going to be left in the bottom? The salt. So when you put salt into water, that is a mixture, because even though you can't see the salt, it's still there. But if you boil the water off, the salt is still there. Okay, so each chemical is maintaining or retaining its own chemical identity and properties. Now, within the mixtures, there are two different types. There's what's called a heterogeneous mixture, and a heterogeneous mixture is one that does not have the same composition throughout. Okay, think about a rock. Take a rock and hit it on something hard and it breaks in half, and you look inside of it, and it's just kind of a random mixture of a whole bunch of different chemicals. Okay, wood is also a good example of a heterogeneous mixture, or even sand. Okay, sand is obviously it's got a little bit of rock in it, it's got a little bit of the sand particles, silicon dioxide in it, etc. Okay, even something like, think about something that you eat, like, I don't know, a Caesar salad from Olive Garden. Okay, when you take a bite of that salad from Olive Garden, and it's got some olives and some croutons and things like that in there, and every bite is going to be different. That's kind of how I remember what a heterogeneous mixture is if every bite is different, it's going to be heterogeneous. Okay, so a salad, and of course from Dairy Queen, a Blizzard. Every bite of that Blizzard is going to be a little bit different. Okay, but if I go to McDonald's and I get a milkshake, hopefully that milkshake all the way through is going to be the same. Okay, and those are called homogeneous mixtures. Okay, so a mixture that is uniform throughout, which means you take bite after bite after bite, like Jell-O. Okay, now Jell-O with bananas in it would be heterogeneous, but just Jell-O, just that the Jell-O part would be a homogeneous mixture. Okay, air is an example of that. It doesn't matter where you breathe it. It's about 78% carbon or nitrogen, 21% oxygen, and about 1% of carbon dioxide and water and other things. Okay, another term, and you're going to see this term a lot this year, homogeneous mixtures. And again, these are typically when you put something solid into water, and remember that creates an aqueous solution, that is called a solution. So anytime you dissolve something in water or create any type of homogeneous mixture, it's called a solution. Okay, remember that state called aqueous. An aqueous solution of salt and water is salt that is evenly mixed with water. Okay, and then our last one for this video is what are called physical and chemical changes. Okay, and in a physical change, sometimes we refer to them as a physical property. A substance changes its physical appearance. See, physical change, physical appearance. Okay, but it doesn't change its chemical composition. Okay, and the main example of that is what's called a change of state. Okay, you go from a solid to a liquid. Well, obviously that's called melting. Or a liquid to a gas, that's boiling. Some of the less common ones. If you convert a solid to a gas, okay, well, when might you see that? Well, carbon dioxide, dry ice, is a solid. And what does it do? Is it immediately, instead of going to a liquid first, it immediately goes to a gas. And that is the process of called sublimation. Again, don't need to remember these, but just so you're aware of them. Obviously, if you're taking a liquid to a solid, you're freezing it. Gas to a liquid, that is called condensation or condensing something. And again, the opposite of sublimation, going from a gas straight to a solid, is called deposition. Okay? Anytime you go from a solid to a liquid to a gas, or vice versa, that is a physical change because it's still the same chemical. It's just now converted to in a different state. Okay, you take CO2 in the solid state, that's dry ice, and let it warm up. Well, then it's going to turn into a gas. Well, it's CO2 here, solid. It's CO2 here, gas. It's still CO2. So that's how you know if it's a physical change, is if its state changes. Okay, a chemical change, or sometimes called a chemical property of something, is when it turns into something different. It's when the atoms rearrange themselves. Okay, if the CO2 reacts with water to create a new compound, that is a chemical change because it's not CO2 anymore. If you take H2O and react it with CO2 and you make H2CO3, well, you had water, you had carbon dioxide, and now you have this substance that's called carbonic acid. Okay, that is a chemical change. Okay, it's not, again, something that it stays the same. It has to be a different substance. Okay, so when hydrogen burns in oxygen and when it reacts, it makes water. Okay, that is a chemical change. You could write a chemical equation that looks like this. Hydrogen gas, oxygen gas makes water. Okay, so you started with hydrogen and oxygen, and now you've made water. Okay, now here's the part that I really want you to think about, because this is something we're going to learn about in Unit 2. Okay, another way to think about it is the following. During a physical change, the intermolecular forces, okay, that's probably a new term. So inter means between. So intermolecular forces are the forces of attraction between one water molecule and another water molecule. Think about water in a cup. Okay, why is that water there? Why is it not turned into a gas? Because there are intermolecular forces. There are forces of attraction between those water molecules that keep them in the cup. And as it, like in a swimming pool, as the heat hits that swimming pool, it can give those molecules enough energy to break away and turn into a gas. Okay? So, during a physical change, the intermolecular forces, again, the attraction between one molecule and another, are either weakened or completely broken. Okay, think about when water boils. When water boils, are you doing basically this reaction right here? Are you taking this reaction right here and going backwards? Are you creating hydrogen gas and oxygen gas? No. When you boil water, it's still water. It's now just in the gas form. Okay? So when water boils, one water molecule separates from another water molecule, but the water still is H2O. Okay? During a chemical change, the okay, and this is where I like to think about the internet versus the intranet. Like within the Pasco School District, if you are within the school district, you can be part of you're on the intranet. But as soon as you connect to something outside of the school district, you're on the internet. Okay, and that is a very, very common term in technology, is the internet versus the intranet. So you work for Microsoft and you're at the Microsoft campus or whatever, and you're just working within their network. Well, then you're on Microsoft's intranet. But if I'm at school or at home, I can't connect to their intranet because I'm not there. Okay, I can get on the internet, which connects my home to all of the other computers in the world. So intra means within. So inter means between. So between one molecule and another. And intra means within. Okay, so in a chemical change, the attractions between the atoms, so not the attraction between the molecules, the attraction between the atoms, which we call the bonds. Okay, the bonds are either formed or they are broken. Okay, if you take water and you run electricity through it, so it's called electrolysis. So when water is electrolyzed, one water molecule will break apart. So this process right here will happen. The H2O will break apart into hydrogen gas and oxygen gas. Okay, and that's it for the first lesson.